Hello and welcome to this introduction guide to the VEXcode V5 blocks by 9204A. I'll walk you through the process of getting started with the VEXcode V5 for PC. Tablet is different and I have no clue how close IQ is to this. So we'll first start with downloading the app. You can also use it online, and links to all of these will be in the description, and links to this repository will also be there. Just hit next, accept, install, and then once it's finished, just launch the V5 app and it will look like this. Let's first go over how the interface works. Your save options, we're only going to be doing blocks in this. VEXcode's recommended for text. You don't need to press the make a new blocks project because this is a new blocks project. We have all of our blocks here. As you can see, there's not many yet. So we have the slot buttons where you can change which slot on the brain it will be under. There is a maximum of 8 slots on the brain, and if you upload code to a slot that already has code in it, it will just overwrite it, no warning. By clicking where it says VEXcode project, you can actually change it to a very creative name. And I cannot type today. I really cannot type today. So, to get all of our blocks to appear, let's add let's add our objects that we need. So you can see that we have these 4 unlabeled buttons under the download buttons. So we'll click the second one that looks like a port, where then we can add our devices. So let's first make a drivetrain, and then we'll say that the left 2 motors are in ports 1 and 2, the right ones are in 3 and 4. Most of the time you won't be using any sort of sensor. If you don't know, then you probably aren't. So these measurements here, these really only matter if you actually are using auton in this, where the autonomous if you tell it to drive 5 inches, if you tell the drivetrain to go forward 5 inches, then it will be looking at this to calculate how much a rotation would be for the entire drivetrain to move. So really only important for that. The track width is the middle of the wheel across the width of the robot to the middle of the other wheel, and wheelbase is from the middle of the wheel to the middle of the wheel lengthwise. So and then there's these gear cartridges. Most of the time you'll be running 18-1, and the way you can tell is if you were to look at the gear, if you were to look at the motor before you put it on, you'll see next to where you put the shaft, you'll see one of these colors, which will be your gear cartridge. The one useful thing here that you'll find is this button here, where you can reverse the direction of the motor. So if the robot's going backwards to what you want, then just select that, and now it will reverse that. So as you can already see, we have a bunch of new blocks. So let's add a controller, and you can see that it says drivetrain because it wants to configure the motor. It wants to configure this controller to handle your drivetrain. So you can actually select this, but you probably don't want an arcade drive like that or like that. You can't. So you can change the way that it is. I'll have tank drive in this example, and then I'll just add another motor, and let's say it's on port 5, and let's just call it flywheel, so it has a nice, pretty unique name. and you can also reverse it here, and it shows you here what forward and reverse will look like. So now we're done with initializing our devices, and as you can see, we have several new things. I'll just make a simple program. So let's just say, we want our drive velocity to be 78%. We want the stopping to be brake, where instead of the robot just coasting as soon as you let go, it applies a little bit of force to slow down the motors, and hold just keeps it that as soon as there's no more power being applied to the motor, apply power to keep the motor in that position, but it can possibly overheat your motors depending on what you're doing. So we'll set the flywheel to just coast, and then as you can tell, our flywheel is not going to be able to actually spin yet. So we need to add an event. So once we press the up button, we want it to spin, but we don't want to have to make it that we have to put another one and say once it's released to stop spinning. Well, if we want to make a toggle button, then let's make a boolean, and we can just call it toggle. So now here are some of the blocks we'll need, and we go to events, or not events. Events is what calls the function. So if I can actually scroll, there we go. So let's say, so when we start, we want the toggle to be false. So then, if toggle's false when you press this, then let's set toggle to true. So then, when you press it again, toggle goes back to false. And what we'll do is we'll take our flywheel and let's put its velocity here to 100%. And then we'll just spin the flywheel. So then once the button is pressed again, we'll then stop it and we can set the velocity to 0. And that's a simple program where you can do that. And if you want to, you can just drag one of these blocks in and just say, here is my toggle button, and it can just float out here. It doesn't need to be inside of anything. So as you can see, we can't actually download this yet. So first we will hook up a USB to the PC, then we'll hook up the USB to the controller or the brain, and then you'll see the brain icon glow green, which then we can press download. And then once it's downloaded, ignore if the controller is saying disconnected. It likes to do that when it's downloading, just ignore that. So then once it's connected, we have two ways to actually start the program. You can from the controller, you can go from the controller or the brain, and you can go to your programs folder, or if you're on the brain, it might be on the main screen. And then just hit run and your code will be running. But if you're on VEXcode Online, you cannot connect to the brain through the controller. It must you must have the USB directly into the brain. So you'll select the brain icon, select connect, Vex will give you some pop-up, just hit continue, and then the browser will give you a pop-up where you might see a few different devices. One you're looking for will be labeled Vex Robotics Communications Port. You might see a couple other things that say Vex. Make sure it says communication port, not user port. If you're comfortable with this and you are familiar with how this works, for actual competition code, I would suggest looking into using Python, as it's pretty easy to learn, and if your code gets pretty complex like ours did, don't let it become the nightmare we let it become. Use C++, and there will be guides on those two as well, and I'll have them linked both in the description, and I'll put a card up in the top right for you. And hopefully this guide was useful for you.